Fluid mechanics problem. So the first question, you have to find out the height of the block that is not submerged into the water. To find out this height, you have to calculate the height of the whole cube and subtract by the height that is submerged into the water, and then you can get height 1. To get the whole height, it's very simple. We have the cube, we know the area, and we know the volume. So height will just be volume over area, which is 1.80 meters cubed over 8.2 meters squared, which is 0.22 meters. So now we know the whole height, and we want to know how much it is submerged into the water. We could calculate this by measuring the difference of the density of the block and the water and multiply them by the whole height. So it would look like this. H2 equals height times density of block times divided by the density of water, which would be 0.22 meters times 650 kilograms over meters cubed over 1,000 kilograms meter cubed. These units cancel out, so it would look like 0.14 meters. Now we know this height. Since we know these two, we could go back to the original equation we made and calculate height 1. So height 1 will be the whole height subtracted by the height that is submerged, this number. So height 1 will be 0.22 meters subtracted by 0.14 meters. And that would be 0.08 meters. Alright, the second question, you have to find out the buoyancy force exerted on this object. So in the earlier question, we found out that the height that is submerged into the water is 0.14 meters. So it's very easy. All you have to do is just plug the numbers in, because the formula for F buoyancy is rho Vg. Rho is the density of the water, which is 1,000 kilograms meters cubed, times the volume that was displaced by the object. So it will be this height, 0.14 meters, times the area, 8.2 meters squared. And then finally, the gravity, acceleration due to gravity, which will be 9.8 on Earth. So 9.8 meters per second squared. And then you plug this into the calculator, and then it would be 112.50.4 Newton. And since it's 2 significant figures, it will be 11,000 newtons. Okay, for the last question, we need to find out how many people we could put on an object before it starts sinking. So, for an object to carry the maximum amount of people, it has to be completely submerged in the water. And then we need to find out how many people could fit. So let's start by drawing a free body diagram. So pretend this is an object, this red dot. Oh my god. There will be a force downwards, Fg, because there's a gravity always. And then there must be F buoyancy, pulling up. And then it has to float, so F net must be 0. So F boy minus Fg. That means F boy must equal Fg, which is pretty simple. And since the equation for F buoyancy is rho Vg, and then Fg is basically mg. Notice we have 2 g's on both sides, so we could cancel each other. So it would just be rho v equals m. Now, we know the density of water, which is 1,000 kilograms meters cubed times the volume that is displaced. So since the volume will be calculated with by height multiplying height by the surface area, and in this case, we are the object must sink in the water. So the total height will be our height this time. So that would be 0.22 meters. We found that out. We got this number in earlier question. So times the surface area, which is 8.2 meters squared. And this, it goes to the mass. So we put this on the calculator. So 1,000 times 0.22 times 8.2 equals to 1804 kilograms, because these units cancel out, will be the mass. Okay. However, so this is how heavy the object could be. Some erase might work here. So when there's a people on the board, the mass of the object would be mass of the object plus mass of people. And we need to know this value in order to determine how many people we could fit. So we know the mass, and the mass of the object would be the volumes times density. So rho v plus mass of people. So mass of people is just the total mass subtracted by rho v. That would be 1804 kilograms minus the density of the object, which is 650 kilograms cubed, times the volume, which would be 8.2 meters squared times 0.22 meters. So that would be 1804 minus 650, 8.2 times. So it would be 631.4 kilograms. So this is the amount of mass we could put on and then it will keep floating. And it says each person weigh 75 kilograms. All you have to do is divide geez, divide 631.4 kilograms by 75 kilograms, which is 8.41. So this is 8.41. We could fit. Well, this means we could fit 8.41 people. However, 0.4 people doesn't exist, so there'll be 8 people maximum could fit on the object, and it will keep floating.
Ray.